Imagine, for the space of a single slow breath, the entire universe small enough to vanish inside the curl of your hand. Not the universe spread wide and cold as you know it now, with its scattered galaxies and its long, patient distances, but the universe at its very beginning, gathered into a speck finer than a grain of dust, warmer than any fire, smoother than still water. There is no sound in this place, for sound has not yet been invented. There is no inside and no outside, no near and no far, only a tiny trembling fullness holding everything that will ever be. And then, in less time than it takes a thought to form, that speck begins to swell, gently at first, and then with a sudden ferocity, stretching outward faster than light itself can run, doubling and doubling and doubling again, until in the smallest sliver of an instant it has grown unimaginably vast. This is the moment the cosmos opened like a flower in the dark, and tonight you are invited to drift slowly through its long, slow story. There is nothing for you to do here, and nothing you must keep. You do not need to follow the numbers, or fix the ideas in place, or remember a single word when the morning finally comes. Let the thoughts arrive the way the first light arrived, having crossed an enormous stretch of time to reach you, asking nothing in return. Some of them will settle somewhere beneath the surface of your mind, and the rest will simply pass on through, the way starlight passes through an open pane and warms no one and is lovely all the same. Let the breath lengthen and grow unhurried. Let the shoulders ease, let the jaw soften, let the small busy machinery of the day wind itself slowly down towards stillness. You're only here to drift through the smoothest beginning the universe has ever known, and to let its slow unfolding carry you towards sleep. What you're about to wander through is one of the boldest ideas in all of science, an idea about the first faint fraction of a second after time began. And it begins, fittingly, with a puzzle, with a few small questions that troubled the people who study the sky, questions that pointed the way toward this strange and beautiful answer. For a long while, those who studied the early universe noticed something that quietly refused to make sense. Wherever they looked across the sky, in every direction, the distant glow left over from the cosmos when it was young appeared almost exactly the same temperature, smooth and even to a remarkable degree. Look one way, and it reads a certain faint warmth. Look the opposite way, across the whole width of the heavens, and it reads that very same warmth, matched to better than 1 part in many thousands. This should not have been possible, for those opposite patches of sky lie so far apart that, in the ordinary telling of things, they could never have touched, never have shared their heat, never have settled into the same even balance. It was as though 2 distant rooms, sealed away from one another since the beginning, separated by a wall no sound or warmth could cross, had somehow arrived at precisely the same temperature down to the last fraction of a degree. The strangeness of this small fact is where the whole story begins to turn. That riddle has a name among those who ponder it, a name as plain as it is patient. They call it the horizon problem, and it rests on a simple truth about light. Nothing can travel faster than a beam of light, and so in the few 100,000 years that had passed when that ancient glow was released, light could only have crossed a certain modest distance, knitting nearby regions together but leaving the far-flung ones forever strangers. Yet the sky is calm and uniform from edge to edge, far beyond what that limited reach of light could ever explain. Something must have stitched the whole expanse into agreement long before that glow was set free, some unseen hand passing across the early universe and smoothing it like a palm drawing a rumpled sheet, flat across a wide and unmade bed. And the search for that smoothing hand is the search that this long night follows. A second puzzle waited alongside the first, and it concerned the very shape of space itself. As far as anyone can measure, the universe is flat, not curved inward like the surface of an enormous sphere, nor curved outward like the flare of a saddle, but flat in the grand geometric sense, so that 2 beams of light set out side by side will travel onward forever, without drawing together or pulling apart. This is a delicate and surprising thing, for the balance required to make space so perfectly level is exquisite almost beyond belief. Tip the early cosmos by the faintest fraction toward one curve, and it would have folded back upon itself and collapsed long ago. Tip it by the same whisper toward the other, and it would have flown apart too swiftly for anything to form. Yet here you rest, in a universe balanced on the knife's edge between those fates, level enough that galaxies could gather and a small world could cool beneath the stars. This second wonder is known, just as simply, as the flatness problem, and it carries the same air of an unlikely coincidence. For space to be as level today as it appears, it must have been level in the beginning to a precision so fine that the mind can scarcely hold it. Balanced more exactly than a pencil set spinning on its point and asked to stand there for the whole age of the cosmos. Left to itself, any small imbalance would grow and grow across the long ages, swelling a slight curve into a great one. So the flatness we see now demands a beginning tuned with astonishing care, and that need for such perfect tuning is a clue, a thin thread leading toward the same hidden answer that the smoothness of the sky requires. There was a third small trouble, stranger than the others, and it had to do with things that were expected but never found. The earliest moments of the cosmos, as the physicists understood them, should have forged a scattering of peculiar heavy objects, knots of pure energy and twisted field, each one carrying a single lonely pole of magnetism, unlike any magnet you have ever held. These were predicted to be born in great numbers and to linger ever after, drifting through space, heavy and stubborn and unmistakable. And yet, in all the long searching, not one has ever been found. The universe, which should have been seeded thickly with these odd relics, appears instead to be entirely empty of them, swept clean, as though some great wind had carried every last one away into the dark. This third riddle is called the monopole problem, and like the others, it whispers of a missing chapter in the story of the beginning. If those heavy relics were truly made, then something must have happened to thin them out, to scatter them so widely that no telescope could ever hope to find one again, diluting their crowded multitude until barely a single example remained in all the reachable universe. A great stretching of space would do exactly that, spreading the relics so thinly across so wide a new expanse that they all but vanish from view, a single bead scattered through an ocean. 3 separate puzzles then, 3 coincidences that no one could explain, and all 3 pointing like 3 fingers toward one single idea. That idea arrived in the opening weeks of 1980, in the mind of a young physicist working late, turning these very problems over in the stillness of his thoughts. His name was Alan Guth, and he was not even studying the shape of the cosmos at first, but chasing those missing magnetic relics, when he saw that a single bold notion might dissolve all 3 troubles at once. What if the infant universe, in its very first flickering moment, had undergone a burst of expansion so sudden and so enormous that it dwarfed everything that came after? What if space itself had stretched not slowly but explosively, ballooning outward by an almost incomprehensible factor in a sliver of time too brief to name? Such a stretching would smooth the sky, level the geometry, and sweep the relics away, all in one stroke. He wrote in his notebook that night a few simple words about a spectacular realization, and the idea he had glimpsed would come to be called inflation. That first version of the idea, lovely as it was, carried a hidden flaw within it, and watching how it was mended is its own small wonder. In the earliest form, the great expansion was meant to end through the sudden appearance of countless tiny bubbles of settled space, each one a place where the field had dropped to its true rest. But the trouble was that the space between those bubbles kept stretching so fiercely that the bubbles could never meet and merge into one smooth cosmos, leaving a froth too broken ever to become a calm and uniform universe. The expansion, in that telling, had no graceful way to stop, and the puzzle of how to end it without shattering came to be called the problem of the graceful exit, a flaw the first picture could not quite escape. The mending came soon after, from other thoughtful minds who reshape the idea into a smoother form, and their refinement is the version most often told today. A physicist named Andre Linde, working alone, and two others, Andreas Albrecht and Paul Steinhardt, working together, each saw a way to let the field roll down by slow degrees, rather than ending in a shattered foam of bubbles. In their picture, the whole of a region descends together, gradually and as one, so that when inflation ends it leaves behind a single smooth and unbroken cosmos, rather than a fractured froth. This reshaped idea, sometimes called new inflation, dissolved the trouble of the graceful exit, and from it grew nearly all the versions of the story that followed. The same restless thinker who helped mend the idea soon imagined an even simpler and more sweeping form of it, one that needed no special arrangements at all. Andre Linde proposed that inflation might begin almost anywhere, in any patch of the early chaos where the driving field happened, by pure chance, to hold a high enough store of energy. In such a patch, the field would begin its slow roll and the great stretching would unfold, no matter how disordered the surroundings, no matter how wild the start. This generous notion, called chaotic inflation, suggested that the great expansion was not a delicate and unlikely event, but an almost natural one, ready to ignite wherever the conditions stumbled into place. It made the birth of a smooth universe seem less a fragile miracle, and more an easy and recurring thing. The beauty of the central idea is that it answers all three puzzles with a single motion, and to feel how it does so is to feel the whole thing click into place. Picture a small wrinkled patch, smaller than anything, warm and uneven and touching itself all over, every part close enough to share its heat and settle into balance. Now let that tiny patch be stretched, swiftly and enormously, until it swells to encompass everything you can now see, and far more besides. The smoothness it had when it was small is preserved and spread across the whole new expanse, so the sky comes out even from edge to edge. Any curve it carried is flattened by the sheer scale of the stretching. The way the surface of a balloon presses flatter and flatter against your eye as you blow it from the size of a plum to the size of a house, until a small patch of it looks like a level wall. And the heavy relics, born before the stretching, are flung so far apart that scarcely one remains within reach. One idea, three answers, and the long night opens out from here. To grasp how violent and how swift this stretching was, you must let go for a moment of every ordinary sense of time, for it unfolded in a span so brief that no heartbeat, no flicker, no instant you have ever known comes anywhere close. The whole episode of inflation is thought to have begun and ended within the first tiny fraction of the universe's first second, in a window that opened perhaps a trillionth of a trillionth of a trillionth of a second after the very beginning, and closed almost as soon as it opened. Within that vanishing sliver, space did its most dramatic work and then fell still again, handing the cosmos over to the slower, milder expansion that has continued ever since. Everything that has happened in all the billions of years that followed, every star and galaxy and still evening, took place in the long, calm aftermath of that first astonishing breath. The universe did its wildest growing before it was a single second old, and then it settled, and has been settling ever since. In that fleeting window, space swelled by a factor so enormous that the numbers themselves begin to lose their footing, stretching by at least 100 trillion times, and very likely far more. A region smaller than a single particle, smaller than anything you could ever see, was blown up in that instant to something larger than a grapefruit, and from there the ordinary expansion carried it onward to the breadth of the visible cosmos. So furious was this swelling that the two edges of that growing patch raced apart faster than any beam of light could ever travel, and yet no rule of nature was broken in the doing, for it was space itself that was stretching, not any object hurtling through it. Nothing moved across space faster than light. Rather, new space opened up everywhere at once, between every point and every other, swelling the distances themselves at a pace light could never match. To picture the scale of it, Imagine a single grain of sand suddenly expanding until it was larger than the entire observable universe is today, and you would still fall short of the true immensity of the stretching. It is a growth without any comparison in ordinary life, a swelling so extreme that every metaphor strains and breaks beneath it. The pace of this growth was unlike anything in the slow expansion you might already know about, for during inflation space did not merely spread but doubled, again and again, in relentless and even strides. Each tiny tick of that early clock saw every distance grow to twice what it had been, and then twice again, and then twice once more, the way a single folded sheet of paper, doubled enough times, would in theory reach beyond the moon. This kind of growth, where a thing keeps multiplying upon itself, builds with a swiftness that overwhelms the imagination. For a few dozen doublings is enough to turn the smallest seed into something cosmic. The universe is thought to have doubled in size at least 60 times over during inflation, and perhaps far more than that, each doubling adding its own enormous measure to the total. There is something almost hypnotic in the rhythm of it, this relentless, ferocious doubling, growth piled upon growth, until the tiny became the boundless. The time it took for space to double during inflation was almost unthinkably brief, so short that the doublings came faster than any rhythm the mind can follow, one upon another in a blur of growth. In the span of a single ordinary second, space would have doubled an immense number of times over, though in truth the whole episode was finished long before even 1 second had passed. To picture it is to imagine a drum beat so rapid that the separate beats dissolve into a single ringing tone, each doubling arriving so swiftly upon the last that the growth seems smooth and continuous, a seamless ballooning rather than a series of steps. The cosmos grew, not in measured stages, but in a headlong rush, doubling upon doubling faster than thought. This kind of swelling, where a thing grows ever faster the larger it becomes, has a particular shape that mathematicians know well, a curve that rises by the barest amount at first, and then sweeps upward without bound. Space during inflation followed exactly such a curve, its size climbing almost imperceptibly in the very first moments, and then soaring nearly straight up as the doublings compounded, each new size feeding a yet faster growth. A geometry of pure, smooth, runaway expansion describes that early universe, an empty space swelling at an ever-quickening pace under the steady push of the field. There is a strange elegance in that curve, the same shape that describes anything that grows in proportion to itself, hear it across the whole of creation in its first instant. Those who study this beginning have a name for each of those doublings, a tidy unit by which they measure the great stretching. They speak of e-folds, and each e-fold marks a stretch of space by a particular natural factor, a little under 3, so that counting the e-folds is a way of counting how thoroughly the cosmos grew. To solve the puzzles of smoothness and flatness, inflation needed to last for at least 60 of these e-folds, 60 deep multiplications of every length, each one stretching space by that same natural factor until the total swelling ran past 100 trillion, and some versions of the story call for many more. There is a real pleasure in knowing that even something as wild as this first expansion can be counted and measured, folded into a single number, the unimaginable made plain and countable by careful minds. You need not hold the number itself, let it rest lightly, the way you might note the depth of a great sea without needing to sound it fathom by fathom. And as that thought drifts past, you may feel your own breathing has begun to slow without any effort, the chest rising and falling in its own unhurried time. There is nothing here to grasp or carry. The universe did all of its frantic growing long before there was anyone to watch, and it asked nothing of you now but that you rest while its old story unwinds, unhurried and low, in the warm dark around you. If something stretched space so violently, the natural question is what could possibly have driven it, and here the answer is as strange and lovely as the stretching itself, for the engine was not a substance but a field. The early universe, in this telling, was filled with an invisible something spread evenly through all of space, a field carrying within it an enormous store of hidden energy. Physicists call this the inflaton, a plain name for the unseen thing that powered the Great Expansion, and it was less like any object you could touch, and more like a faint tension humming through the emptiness, a potential waiting to be released. While that field held its energy high, it pushed space apart with a relentless outward pressure, and as long as it lingered in that elevated state, the doubling went on and on. It is a curious thought, that the whole immense cosmos may have been blown outward by nothing more solid than a field of pure energy, an invisible breath filling the dark. The peculiar power of this field came from a quality of certain energy that runs against every instinct you carry from ordinary life, a kind of energy that does not thin out as space expands. Stretch a room full of ordinary gas to twice its size, and the gas grows thinner, its pressure falling, its push fading away. But the energy held within that early field behaved in the opposite manner, for as space swelled, the field's energy stayed at the same density, every new region of space filled as fully as the old. This meant the more space grew, the more total energy there was to keep it growing, a strange and self-feeding abundance, a push that did not weaken but renewed itself with every doubling. There is a dreamlike quality to this, an expansion that fed upon its own growing, the universe pulling itself ever wider by a power that never ran low, like a tide that rises higher the farther it comes in. This odd, undiluting energy is sometimes described through the idea of a false vacuum, a name that hints at how deceptive emptiness can be. We tend to think of empty space as truly empty, a perfect nothing with no energy at all. But the early universe may have rested in a different sort of emptiness, a vacuum that looked empty yet brimmed with energy locked inside the field. This was a false bottom, a state that seemed like the lowest place the field could rest but was not the true lowest place at all, a valley with a hidden valley lying still deeper below. While the field lingered in that false and elevated calm, its trapped energy drove the great stretching of space. The true emptiness, the real and final rest, lay further down, and the whole drama of inflation was the long descent of the field toward that deeper floor, like meltwater pooling in a high mountain basin before it finds the notch that lets it fall. The way that field finally came down from its high perch is often pictured as a long, slow roll, and the unhurried ease of that image is part of why the universe turned out the way it did. Imagine a wide, almost level plane tilted by the smallest degree, and a ball set rolling so lazily across it that it barely seems to move, easing toward the distant edge where the ground at last falls away. While the ball crosses that nearly flat ground, scarcely gathering speed, the field holds most of its energy, and inflation continues, space doubling all the while. This descent is called slow roll, and it had to be unhurried, for if the field had plunged down at once, the great expansion would have ended too soon, before it could smooth the sky or flatten the geometry. The lingering, the patient creeping across the level plane is what gave inflation the time it needed to do its work. There is a lesson hidden there in how the lightest and most measured of motions can shape something as large as a universe. When at last the field reached the edge of that long plane, and the ground fell away beneath it, inflation came to its close, but the field did not simply vanish into silence. It tumbled down into the deeper valley, and arriving there it shook, oscillating back and forth around the true bottom like a pendulum settling, and in that shaking it poured out all the energy it had carried for so long. That outpouring filled the newly enormous universe with a flood of particles and radiation, a sudden blossoming of warmth and light, where moments before there had been only the cold tension of the field. In an instant, the dark and empty expanse became a blazing sea of matter and energy, hotter than the core of any star, packed so densely that light itself could not move freely, but only ricochet endlessly through the glowing fog. This great releasing has a name as warm as the event itself. It is called reheating. The moment the cosmos was filled with fire, the instant the empty, stretched and silent expanse was set glowing with the first true heat of creation. The end of inflation was not an ending at all, but a kindling, the lighting of the long blaze that became everything, the single flash from which all the warmth in the universe would slowly descend. That moment of reheating is, in a sense, the true beginning of the warm and familiar universe, the place where the ordinary story of cooling and forming finally takes up its thread. Everything that the older accounts of the cosmos describe, the hot dense plasma, the forging of the lightest elements, the long cooling towards stars, all of it begins here, in the fire that the dying field left behind. Inflation set the stage, smoothed and flattened and emptied it, and then handed it over, glowing, to the slower processes that would fill it with structure across the ages. There is something graceful in this passing of the torch, the wild first expansion giving way to the steady warmth that followed, the frantic doubling settling at last into the long even cooling that carries on even now. From this kindled fire everything you have ever known slowly took shape, and yet for all that inflation smoothed the universe into evenness, it could not have made it perfectly smooth, and in that small imperfection lies perhaps the loveliest part of the whole story. Had the great stretching ironed space utterly flat, with not the faintest ripple anywhere, then nothing could ever have gathered, no galaxy formed, no star kindled, no small world cooled beneath them. A perfectly smooth cosmos would have stayed empty forever, a featureless mist with nothing to draw itself together. But inflation left behind the tiniest of wrinkles, faint variations from place to place, a hair more density here and a hair less there, and from those whispers of unevenness everything you see was eventually born. The seeds of all structure, of every galaxy and every cluster of galaxies, were sown in those minute ripples, like the faintest fingerprints pressed into wet clay an instant before it set forever. The origin of those world-making ripples is one of the most astonishing claims in all of science, for they began as the faintest flickers in the very smallest realm, the restless quantum jitter that fills even empty space. Down at the tiniest scales the world is never perfectly still, for the rules that govern the very small forbid any field from holding a single fixed value, so that energy is always trembling, flickering up and down by the smallest amounts, a ceaseless faint shimmer woven into the fabric of emptiness itself. In the early universe, the inflaton field carried this same fine trembling, tiny fluctuations rising and falling across it, here a touch more energy, there a touch less. These were the most delicate of variations, far too small to matter on their own, mere whispers in the quantum dark. And yet they were about to be made enormous. What inflation did with those tiny tremblings is the heart of the wonder, for the great stretching of space took those minute quantum ripples and blew them up to colossal size, freezing them into the universe as lasting variations in its density. A fluctuation that began impossibly small was caught up in the doubling of space and stretched, along with everything else, until it spanned great reaches of the cosmos, far too large to fade away. In this way, the most fleeting flickers of the quantum world were lifted up and made permanent, printed across the heavens as faint patterns of a little more and a little less. The smallest things in existence, magnified by the largest expansion in existence, became the blueprint for everything that followed. There is a profound beauty in that thought, that the galaxies themselves, in all their grandeur, grew from the faintest quantum whispers caught and frozen in the stretching of space. The way those tiny ripples were locked in place has a clean logic worth resting within, for it turned on a kind of horizon, a reach beyond which parts of space could no longer speak to one another. While inflation stretched space so swiftly, any small ripple was quickly carried until its two sides lay too far apart to influence each other within the time available, and at that moment the ripple could change no more, frozen by the very speed of the expansion. So each trembling, as it was stretched past that reach, was caught and held, fixed in size and shape, set aside like a photograph taken and never altered again. The faster the stretching, the sooner each ripple was frozen, locked away to wait through all the ages that followed. Long after inflation ended, as the universe expanded at a calmer pace, those frozen ripples slowly came back within reach, their two sides able to feel one another once more, and only then did they begin to shape the gathering of matter. A ripple that had been locked away in the first instant would, ages later, return to the realm where gravity could act upon it, and there it would begin its slow work of drawing matter together or letting it thin. The grandest structures, frozen earliest and largest, were the last to reawaken, gathering across the longest spans. The smaller ones stirred sooner. There is a deep patience in this, ripples sown in the first flicker of time lying dormant for ages, then waking one by one to build the galaxies in their slow and ordered turn. There is a dizzying thought folded into all of this, for the ripples that became the largest things in the universe were once smaller than the smallest scales physics can even describe. Before inflation stretched them, the patterns that would grow into great clusters of galaxies were so tiny that they lay below the finest length nature seems to allow, deep in a realm where our very ideas of space begin to falter. The great stretching lifted them up from that unfathomable smallness and carried them across every scale to cosmic size. To hold that still in mind is to sense the full sweep of inflation's reach, joining the very smallest imaginable to the very largest, the floor of physics to the ceiling of the cosmos, in one continuous stretch. And here the account turns back toward you in a way that is almost tender, for those frozen ripples are not some distant abstraction, but the very reason you and everything around you exist. Where inflation left a little more density, gravity later had a little more to pull upon, and so matter slowly gathered there across the long ages, drawing inward, growing denser, until clouds of gas collapsed into the first stars, and stars gathered into galaxies, and galaxies into the great clusters that web the cosmos today. Every structure you have ever known, every star you have ever seen, every atom of the world beneath you, traces its lineage back to one of those faint quantum tremblings, magnified in the first instant of time. You are, in the most literal sense, the distant descendant of a fluctuation, a single ripple in a field stretched wide enough to hold 100 billion galaxies. The faint patterns that inflation printed across the early cosmos did not stay forever hidden, for they left a trace we can still read today, woven into the oldest light in all the universe. When the cosmos was a few 100,000 years young, it cooled just enough for the swirling fog of its early plasma to clear, and the light that had been trapped within was set free to travel onward, streaming across space ever since. That ancient light still surrounds you now, stretched and cooled by the long expansion into a faint glow of microwaves, the same low radiation that fills the sky in every direction. It is the afterglow of the universe's fiery youth, the most distant thing any instrument can see, an even warmth lingering everywhere at once, and within its subtle pattern lies the fingerprint of inflation. Across that ancient glow, when it is mapped with great care, there appear the faintest of variations, patches very slightly warmer and patches very slightly cooler, mottling the sky in a delicate and intricate pattern. These tiny differences, no more than a few parts in 100,000, are the direct descendants of those frozen quantum ripples, the places where the early universe was a little more dense or a little less. To gaze upon a map of that mottled glow is to look upon the seeds of everything, the faint unevenness from which all galaxies grew, recorded in light older than any star. There is something deeply moving in the fact that we can hold such an image at all, a portrait of the infant cosmos, its first faint wrinkles laid out for any careful eye to study, the baby picture of all that exists. The first clear glimpse of those faint variations came from a spacecraft lifted above the disturbances of the air, and the moment of its discovery was a landmark in the study of the beginning. A satellite given over wholly to measuring the ancient glow swept the whole sky and, after long and careful work, revealed at last the tiny ripples mottling its warmth, the first direct sight of the seeds from which galaxies grew. The The differences it found were almost unimaginably small, mere millionths of a degree from place to place, and yet they were unmistakably there. The long-sought wrinkles in the infant cosmos brought at last into view. Those who led that work were honoured with the highest prize in their field, for they had given humankind its first true image of the universe's earliest light. That early portrait was dim and blurred, and so finer instruments followed, each mapping the ancient glow in ever sharper detail, until its faint pattern was charted across the whole sky with exquisite care. A later spacecraft traced the ripples more finely still, and a third, finer yet, drew so precise a map of that primordial light that its delicate mottling could be studied down to the smallest features. With each new mission, the picture grew clearer, the faint wrinkles resolving into a rich and intricate pattern, a map of the infant universe more detailed than the earlier watchers could have dreamed. It is one of the great triumphs of dogged instrument building, this patient sharpening of the oldest image there is, refined across the decades by careful hands. The warmth of that ancient glow is itself a marvel, for it has cooled across the long ages to a temperature only a little above the coldest possible cold, the deep chill from which nothing can fall further. The light that once blazed at the heat of the early cosmos has been stretched and cooled by the long expansion, until it now lingers at barely 3 degrees above that absolute floor, an even warmth filling all of space. Across 13 billion years, that fierce primordial fire has been drawn out and gentled by the swelling of the universe, its blazing white shifted down through red and on into invisible microwaves, until what was once brighter than any sun has become a whisper of warmth, detectable only by the most patient instruments. To know that the whole sky glows with this thin remnant heat, the same in every direction, is to feel the universe wrapped in a single seamless blanket of its own ancient fire, cooled now almost to stillness. You rest in truth within that faint warmth, bathed on every side by the cooled light of creation. That cooled light carries another kind of perfection, for its colour, spread across all its shades, forms one of the smoothest and most flawless patterns nature has ever been found to make. When the ancient glow is parted into its full range of hues, it matches, with astonishing exactness, the ideal pattern that a perfectly even warmth would produce, smoother than any glow ever measured in any laboratory on Earth. This deep perfection tells of a cosmos that was once exquisitely uniform and evenly cooling, exactly the calm and balanced beginning that inflation would leave behind. There is an austere beauty in that flawlessness, the universe's oldest light proving to be among the most perfect things ever observed, a smoothness woven into creation at its very dawn. What makes that mottled pattern so precious is that its particular character matches, with fine exactness, what inflation predicts it should be, and this agreement is among the strongest reasons to believe the story is true. Inflation foretold that the ripples should come in a certain balance across different sizes, neither favouring the largest scales nor the smallest, but spread in a particular even way that physicists can describe with care. When the ancient glow was finally measured in fine detail, the pattern of its variations matched that prediction beautifully, the ripples falling almost exactly as the theory had foreseen. It is a rare and wonderful thing in science, to make a prediction about the first sliver of a second after time began, and then, ages later, to find it written plainly across the sky. The agreement does not prove the idea beyond all doubt, but it lends it a deep and durable credibility, a sense that this strange tale may truly describe how the cosmos came to be. Woven into that ancient glow, there is also the faint memory of sound, real waves of pressure that once rolled through the hot early plasma, and their pattern offers yet another confirmation of inflation's gift. In the young, dense universe, the frozen ripples set the early gas ringing, sending sound waves rippling outward until the moment the glow was released, fixing their pattern forever into the warmth of the sky. When that pattern is measured, the sizes of those ancient sound waves fall exactly where they should, if the ripples were sown all at once in a single early instant, just as inflation describes. To find the echo of primordial sound matching the theory so closely is to hear, in a sense, the faint ringing of the infant cosmos, tuned by the first stretching. The very fact that those sound waves were all in step, rising and falling together across the whole sky, points back once more to a single common beginning for the ripples. Had the variations been sown at many separate moments, the early sounds would have started at scattered times and fallen out of rhythm, blurring the pattern in the ancient glow. Instead, they ring in unison, their crests and troughs aligned, exactly as they would if every ripple were born together in one first instant and then set free to ring. This shared rhythm, this harmony across the heavens, is among the clearest signs that the seeds of structure share a single origin in time, struck all at once like a chord. There is reason to dwell a moment on the sheer abundance that the end of inflation poured into the cosmos, for the energy of the dying field became a number of particles so great it lies utterly beyond counting. When the field tumbled to its rest and gave up its store of energy, it flooded all that enormous new space with so immense a tide of matter and light that the particles created would defy any tally the mind could hold, more than the grains of sand on every shore, more than every such grain many times over. From near emptiness in an instant came an ocean of warmth and substance, the raw abundance from which all things would be made. There is a hushed awe in that, the universe passing from cold and silent emptiness to overflowing fullness in a single kindling stroke. The way those ripples spread across different sizes is captured in a single graceful number, a measure of how the variations change as you look at smaller and smaller scales. If the ripples were exactly the same strength at every size, that number would be precisely 1, a perfectly even sharing across all scales. But inflation predicts that the number should fall just slightly below 1. The ripples are a touch stronger on larger scales than on smaller ones, a faint tilt rather than perfect evenness. And when the ancient light was measured with exquisite care, that number came out to be just a little less than 1, close to 96 or 97 parts in 100, exactly the slight tilt the theory had foreseen. To find such a delicate prediction confirmed, a tiny deviation from perfect balance anticipated and then observed, is one of the great triumphs in the study of the beginning. There is a quiet grace in the history of that number, for the idea that the ripples should be shared almost evenly across all scales was guessed by a few thoughtful minds even before inflation was dreamed of, on the strength of pure elegance alone. They reasoned that a universe sown with ripples of no special size, neither favouring the great nor the small, would be the simplest and most natural kind, and they proposed such an even sharing without knowing what might cause it. Years later, inflation arrived and gave that elegant guess a reason at last, showing exactly how the great stretching would produce such a balanced spread, and even predicting its faint downward tilt. To see an old intuition of beauty confirmed and explained by a later theory is one of the deep pleasures of science, elegance leading the way toward truth. The slight tilt itself carries a further meaning, almost a story about time, for it tells us that the ripples sown later in inflation were a touch weaker than those sown earlier, a slow fading as the great stretching wore on. Because the field rolled gradually down its slope, its trembling grew slowly fainter as inflation aged, so the ripples frozen near the end came out a little fainter than those frozen near the beginning. The small downward tilt in the sky is therefore a record of inflation slowly winding toward its close, the ripples slowly diminishing as the field neared its rest. To read that tilt is to sense the slow aging of the first instant, the great stretching slowly tiring as it approached its end. That faint tilt in the pattern carries a meaning that reaches back to the very nature of inflation, for it reflects the shallow slope of the field as it rolled slowly down toward its rest. Because the field was not perfectly level as it descended, but tilted by the smallest degree, the ripples it left behind were not perfectly even, but tilted as well, slightly favouring the larger scales over the smaller. The measured tilt of the sky is therefore a kind of distant echo of the shape of that early plane, the faint incline down which the field crept, preserved across all the ages in the pattern of the oldest light. To read that tilt is, in a sense, to feel the shallow slope of the ground over which the universe rolled into being, a delicate trace of the first motion of all written softly into the heavens for us to find. Inflation makes a further promise about the character of those ripples, predicting that they should be random in a particular gentle way, scattered in the bell-shaped spread of pure chance. Because the ripples were born from the formless trembling of the quantum world, magnified all together, they ought to carry no hidden design, no special arrangement, only the smooth statistical evenness of countless tiny flickers added up. When the ancient glow is studied for any secret pattern, any departure from that pure randomness, almost none is found, the ripples falling just as scattered and featureless as the theory foretold. There is a deep beauty in that the seeds of every galaxy were sown not by some intricate plan but by the barest randomness, the faint statistical hush of the very small. The ripples carry yet another quality that inflation predicts, a sameness in how every kind of matter and energy was disturbed together, all stirred in the very same measure. Where the early universe was a little denser, every ingredient was denser there together, the ordinary matter and the light and the rest all rising and falling in unison, as though a single hand had pressed upon them all at once. This shared and even disturbance is exactly what the great stretching would produce, for inflation magnified a single field's trembling and impressed it upon everything alike. To find that all the contents of the cosmos were ruffled together in one common rhythm is to see another mark of that first instant, written softly into the oldest light. Perhaps the most telling sign of all is that the ripples reach across distances so vast that, in the ordinary telling, nothing could ever have coordinated them, and only inflation offers a natural way to explain it. Among the variations in the ancient glow are agreements stretching over spans so wide that light, in the time available, could never have crossed from one side to the other to arrange them. Such far-reaching harmony should have been impossible, and yet it is plainly there, for inflation stretched those patterns from a tiny patch that once touched itself all over, carrying their agreement across reaches that later grew far too large for any signal to span. This quiet impossibility, resolved so naturally by the great stretching, is among the strongest hints that inflation truly happened. There is yet another signature that inflation is thought to have left behind, fainter and more elusive than the ripples in the ancient glow, a trembling not of matter but of space itself. As the universe stretched so violently in that first instant, the great expansion is believed to have set space quivering, sending out ripples in the very fabric of the cosmos, waves of gravity rolling outward through all that exists. These are not waves upon any surface, but waves of space itself, faint stretchings and squeezings of distance travelling onward from the moment of creation, the faint reverberation of the universe's first enormous motion. They would be the oldest sound the cosmos ever made, if sound it could be called, a silent ringing left over from the birth of everything, still passing through the dark around you even now. These ripples in the fabric of space are known as gravitational waves, and if inflation truly made them, they would carry within them a direct message from the first sliver of time, a thing almost beyond hope to read. Unlike the ancient glow, which shows us the universe a few 100,000 years after the beginning, these primordial waves would have been born in the very instant of inflation itself, far earlier, far deeper into the dark. To detect them would be to reach back nearly to the beginning of time, to sense directly the trembling of that first expansion, an echo older than light, older than atoms, older than anything we have ever touched. It is among the great dreams of those who study the cosmos to one day catch this faintest of whispers and hear, in it, the universe taking its very first breath. Catching such a whisper is extraordinarily difficult, but there may be a way, for those primordial ripples would leave a subtle twist in the ancient light, a faint swirl that nothing else could easily make. As the waves of space passed through the early cosmos, they would have stirred the oldest light, imprinting upon it a particular curling pattern in the way that light is oriented, a delicate spiral signature unlike any other. Physicists searched the ancient glow for this faint swirl, knowing that if they ever found it clearly, it would be among the strongest possible signs that inflation really happened, a direct trace left by the trembling of space at the very dawn of time. The search is patient and painstaking, for the signal, if it exists, is fainter than almost anything else in the sky, a whisper beneath a whisper, waiting to be heard. That faint swirling pattern in the ancient light has a quiet, technical name, and the chase to find it has become one of the great adventures of modern cosmology. The curl that primordial waves would leave is called a particular mode of the light's orientation, a swirling kind that, unlike the simpler patterns, cannot be made by ordinary ripples in matter alone, and so would point almost uniquely to the trembling of space itself. The instruments that hunt for that twist must themselves be chilled to a cold deeper than almost anything in nature, their delicate sensors cooled to a whisper above the lowest possible temperature so that their own faint warmth will not drown the signal from the dawn of time. To catch a whisper from the beginning, the listeners must first fall almost perfectly silent, every stray flicker of heat stilled, every trembling hushed, the detector colder than the ancient glow it seeks. There is a kind of reverence in that, the patient cooling and stilling of an instrument until it is calm enough to hear the universe's first breath. Only in such deep and engineered quiet can so faint a message be heard at all. Telescopes built in the coldest, driest, stillest places on Earth, where the air barely disturbs the faint glow from above, stare patiently at the sky season after season, sifting its light for this elusive twist. And as you rest here, that search goes on, somewhere beneath the same stars, patient minds reaching back toward the first instant of all things, hoping to catch the faintest curl of light that the beginning left behind. The strength of that faint swirl, were it ever found, would tell us something precious, for it measures how powerfully space itself trembled during inflation, and so reveals the energy at which the great stretching ran. A stronger swirl would mean a fiercer trembling, a higher energy driving the expansion, a fainter one, a milder birth. Physicists capture this in a single delicate ratio, a comparison between the trembling of space and the rippling of matter, and the value of that ratio would point directly to the conditions of the first instant. So far, the swirl has stayed below the reach of even the finest instruments, telling us only that the trembling, if it exists, is faint, and that the energy of inflation, while vast, may lie a little lower than some had hoped. If the great stretching ran at the highest energies imagined for it, those energies would reach toward a realm where the separate forces of nature are thought to merge into one, a unity glimpsed only in the most extreme conditions. In the present cool universe, the forces that shape the world stand apart, each with its own character, but in the searing heat of the very early cosmos, they are believed to have flowed together into a single grand force. The energy of inflation may have brushed against that lofty scale, the very threshold where the forces unite, far beyond anything our machines could ever produce. To study the first instant, then, may be to glimpse physics at the height where all of nature's forces become one, a unity hidden everywhere now beneath the cooled and separated world. A few years ago, that long search produced a moment of breathless excitement, when one team announced that they might have caught the very swirl they had been seeking. They had stared for years through a telescope at the bottom of the world, in the still and frozen air above the South Pole, and in their data they found a curling pattern that looked, for a thrilling while, like the long-sought signature of inflation's gravitational waves. The news spread swiftly, and for a time it seemed the universe's first trembling had been heard at last, a direct echo of the beginning caught and held. There was a sense, in those days, of standing at the edge of something profound, of nearly touching the first instant of time through the faint twist of ancient light. but the story of that discovery carries a lesson in patience and care. For when other watchers looked more closely, the signal proved more complicated than it had first seemed. It turned out that some of the swirling pattern could be explained not by primordial waves at all, but by fine dust drifting within our own galaxy, tiny grains that twist starlight in a way that can mimic the sought-after signature. The careful work of separating the true cosmic whisper from this nearer haze showed that the original claim could not stand on its own, and the announcement was, in time, set aside. There was no failure in this, only the slow and honest self-correction that lies at the heart of how we come to know anything at all, the patient sifting of signal from shadow, truth from its near likenesses. That episode, far from dimming the search, only deepened it, and the hunt for inflation's faint trembling continues today with ever greater care and ever finer instruments. New telescopes rise in the high, dry deserts and upon the polar ice, each more sensitive than the last, each peering more keenly into the ancient light for that elusive curl. The lesson of the earlier excitement was not to abandon the dream, but to pursue it with deeper rigour, to account for every grain of nearer dust, to be certain beyond doubt before declaring that the first breath of the universe had truly been heard. And so, the watching goes on, patient and determined, the great question still open, the faint whisper still waiting somewhere beneath the swirl of light for a patient enough ear. You may let your own listening soften now, the way the night listens, attentive yet at ease, asking nothing, simply present in the dark. The very idea that the universe might one day reveal its own beginning through such faint signals points to something remarkable about inflation, for it makes predictions that can actually be tested, and that is what lifts it from a beautiful story into genuine science. A tale about the opening flicker of the universe's earliest moment might seem forever beyond any checking, a thing one could only imagine and never confirm. But inflation is not so. It foretells the smoothness of the sky, the flatness of space, the particular pattern of the ancient ripples, the slight tilt in their sharing across scales, and the possible swirl of primordial waves, and each of these can be measured and compared against what the theory says. Several of those predictions have already been confirmed with quiet precision, and that is why the idea is taken so seriously. It does not merely soothe the puzzles away, it stakes itself on what we might see, and so far much of what it promised has come true. For all its successes, inflation remains, in the deepest sense an idea still being tested, a beautiful framework rather than a closed and finished book, and there is a candour in holding it that way. Those who study the cosmos do not claim to know with certainty exactly how the first instant unfolded, nor precisely what the driving field was, nor even whether inflation is truly the whole answer. Among those rival notions are milder stories in which the universe does not begin with a sudden stretching at all, but instead passes through a great turning point, a slow contraction that reaches a smallest moment and then rebounds into expansion. In these bouncing pictures, what we call the beginning is not a true origin, but a passage, the cosmos easing through a narrow gate from a previous phase into our own, smoothing itself in the long squeeze rather than in a swift outward burst. Some imagine two vast realms drawing slowly together and touching, kindling the warmth of our world in that slow meeting. These ideas remain less tested than inflation, yet they remind us that the great puzzles might have more than one good answer, and that the story of the beginning is not yet finally told. There is an honest debate too among thoughtful minds about just how cleanly inflation solves the very puzzles it was made for, and there is grace in holding that debate openly. Some have asked whether the special conditions inflation needs to begin, the right field in the right state, are themselves a kind of fine arrangement, trading one coincidence for another. Others answer that inflation can start from a wide range of beginnings and still do its smoothing work, requiring little special tuning at all. This back and forth is not a weakness, but the ordinary breathing of science, careful people pressing an idea from every side to learn how much it can truly bear. The questions remain genuinely open, and there is a dignity and a field content to keep asking them. For all these unsettled questions, one of inflation's gentlest suggestions is that the universe may be far vaster than the part we see, perhaps even endless, stretching on without any edge at all. The great expansion would have carried space so far beyond our horizon that the true cosmos might reach onward forever, an unbounded expanse of which our visible portion is the merest speck. There may be no wall anywhere, no rim where the universe stops, only space continuing on in every direction past all possibility of seeing. To rest with the thought of an endless cosmos is to feel a vastness almost too vast to fear, a boundlessness in which your own small warmth is cradled, here in this one corner of an expanse without end. There are many versions of the idea, differing in their details, and rival notions too, other attempts to explain the smoothness and the flatness of the world. The search for the swirl of primordial waves is, in part, a search to narrow these possibilities, to learn which version of the story the universe actually followed. There is no shame in this uncertainty, only the ordinary patience of science, content to hold a powerful idea lightly while it gathers the evidence to know it better. One of the strangest and most haunting consequences of the idea is that, once inflation begins somewhere, it may be almost impossible to stop everywhere, and this leads to a notion as vast as it is dreamlike. In many versions of the theory, while the great expansion ends in one region and settles into a calm universe like our own, the field elsewhere lingers on its high perch, and that lingering region keeps inflating, growing faster than it can ever finish. New pockets settle down here and there, becoming their own calm universes, while the space between them goes on stretching without end, forever spawning still more pockets. This endless, self-renewing expansion is called eternal inflation, and in its picture the great stretching never truly stops at all, but goes on somewhere always, birthing universe after universe in an unending cascade. The reason the great stretching might never wholly stop lies in that same quantum trembling that seeded the galaxies, for the field's faint flickering can, in places, nudge it back up the slope even as it tries to roll down. While in most regions the field creeps steadily toward its rest and inflation ends, in some the random quantum kicks happen to lift it higher again, renewing the expansion there and keeping it going. Because the inflating regions grow so explosively, these rare upward nudges are enough to outpace the settling, so that somewhere the great stretching is always being renewed. It is a strange mechanism, the same tiny trembling that built the galaxies also keeping inflation alive forever in the endless reaches beyond our sight. To feel how slender the seed of our whole visible cosmos truly was, consider that the patch which grew into everything we can now observe began, just before inflation, smaller than almost any length the mind can picture, a speck of unthinkable tininess. From that vanishing scrap of space finer than the smallest particle, the great stretching drew out all the room that all the galaxies would ever fill, everything you can see in every direction, to the very edge of the observable, unfolded from a beginning so small it defies all ordinary comparison. To hold that in mind is to cradle the whole of the visible universe as it once was, a mote too small to name, finer than the smallest particle, swelling in an instant into the boundless sky beneath which you now lie. Every reach of space that all the galaxies would ever fill was drawn, in that single flash, out of a speck you could never have seen. If eternal inflation is true, then what we call the universe, with all its galaxies and all its distances, may be but a single quiet bubble among countless others, one calm pocket in an endlessly inflating sea. Each bubble would be its own self-contained cosmos, settled out of the great stretching at its own moment, and between them would lie vast reaches of space still expanding furiously, forever keeping the bubbles apart. We could never reach another, never see one, for the inflating space between would carry them away faster than any signal could ever cross. This grand vision of a multitude of universes budding endlessly from the same restless field is sometimes called the multiverse, and whether or not it is true, There is something humbling in even imagining it. Our whole vast cosmos perhaps no more than one soft bubble adrift in an unimaginable foam. You need not believe in that boundless foam to feel the strange smallness it offers, an image that drifts through the mind like a dream half remembered. Whether our universe stands alone or floats among countless siblings, the thought sets every ordinary worry against a backdrop so vast that it shrinks to almost nothing. There is a clear peace in being so small, one lit speck beneath a sky that may be one of endlessly many, a single bubble adrift in an unimaginable foam of worlds. It is worth pausing to feel the sheer scale of what inflation accomplished, for the region that became everything you can now see began as something smaller than the smallest thing you could ever name. Before the great stretching, the entire patch of space that would grow into the visible universe, with its hundreds of billions of galaxies, was packed into a volume far tinier than a single atom, smaller than the heart of an atom, smaller than almost anything words can hold. Every galaxy you could ever see through any telescope, every star within each one, every world circling those stars, all of it was folded into a point you could have lost 1 billion times over inside the nucleus of a single atom. From that vanishing speck in a flicker of time came all the room that all the stars would ever need, the whole vault of the night sky unpacked from a seed beyond the reach of sight. To sit with that thought is to feel the universe not as something fixed and enormous from the start, but as something that grew, that swelled from the unthinkably small to the unthinkably vast, and that you yourself live now within the long aftermath of its growing. The thing that drove all this, that mysterious field with its undiluting energy, behaved in a way that physicists describe through a strange and beautiful property, a kind of pressure that pulls instead of pushing. Ordinary pressure, the kind in a balloon, pushes outward and resists being squeezed, but the energy of the early field carried a pressure of the opposite sign, a tension woven through space that, by the deep rules of gravity, drove everything apart rather than together. It is one of the surprising turns of the theory, that a pressure pulling inward, in the strange arithmetic of the cosmos, produces a push outward upon space itself, an expansion rather than a collapse. This odd inward tension is what gravity reads as a command to stretch, and so the universe flew apart under the influence of a force that, in any ordinary thing, would have drawn it close. The world, at its beginning, ran on rules that turn our everyday sense clean upside down. There is a deep and beautiful balance hidden in how inflation built so much from so little. For the enormous energy it poured into matter may be offset by the energy stored in gravity itself, which counts, in a strange way, as a kind of debt. As the great stretching filled space with energy and matter, it also opened vast gulfs of gravitational pull between everything, and that pull carries a negative measure that may balance the positive energy almost exactly. In this strange accounting, the universe may have cost almost nothing at all to make, its great fullness and its great emptiness balancing to a quiet near zero. There is a wonder in that thought, a cosmos of unimaginable abundance that may, in the deepest reckoning, weigh as light as nothing. That strange possibility, that everything might have arisen from almost nothing, is among the most haunting suggestions of the whole idea, and it carries a deep peace rather than any unease. The vast cosmos, with all its galaxies and all its light, may have grown from the tiniest seed at almost no cost, the great abundance of the world balanced by the great pull woven through it. To dwell on that is to feel how lightly the universe sits upon its own foundations, an immensity of stars and distance that may, when the final sums are taken, come to almost nothing at all. There is a comfort in a cosmos so lightly born, the positive fullness of everything, and the negative pull of gravity settling in the end to a balance near zero. This idea of a tension in space-driving expansion is not entirely foreign to the universe even now, for something faintly like it seems to be at work again in our own late cosmic age. Astronomers have found that the expansion of the universe, after billions of years of slow slowing, has begun once more to quicken, as though some subtle energy spread through empty space were pushing the galaxies apart anew. The discovery of that present-day quickening came as a great surprise, gathered from the faint light of distant, exploding stars scattered across the depths of space. Those who measured the glow of such far-off beacons found them dimmer than expected, as though the expansion carrying them away had been speeding up rather than slowing, pushing the galaxies apart faster and faster across the recent ages. It was an unlooked-for finding, honoured with the highest prize in the field, and it revealed that the universe is not coasting towards stillness, but quickening once more, driven by some faint energy spread through the void. To know that the cosmos is quickening even now in its old age is to feel that the great stretching of the beginning has a faint and distant echo still at work. This present-day push is far weaker and far slower than the furious expansion of inflation, but it carries a family resemblance, a hint that empty space may always hold some faint energy that drives it wider. Whether the two are truly related remains an open and fascinating question, but there is a pleasing symmetry in the thought that the universe may have begun with a great burst of such expansion, and now, in its old age, feels a faint and distant echo of the same. The energy that drives the present-day quickening even shares a name with inflation's deepest nature, for both are forms of what physicists call vacuum energy, the strange notion that empty space itself is never truly empty. In this view, the vacuum is not a barren nothing but a still reservoir, holding a faint and pervasive energy simply by being space at all. During inflation, that energy was immense, and it drove the great stretching. Today, it appears to be vanishingly small yet still enough across the vastness of the cosmos to push the galaxies slowly apart. The idea that emptiness has a substance, that the void itself can hold energy and shape the fate of everything, is among the most profound and unsettling discoveries of modern physics, a reminder that even nothing, it seems, is something after all. Inflation also offers an answer to one of the oldest and most natural wonders a person can hold, the question of why the universe is so large, why there is so very much of it. Without inflation, there would be no clear reason for the cosmos to be as vast as it is, no explanation for the staggering reaches of space that hold the galaxies. But the great stretching makes the answer simple and quiet. The universe is enormous because, in its first instant, it grew enormously, blown up from a speck to a vastness in a flicker of time, and the visible cosmos we know is only the small portion of that swelling we are able to see. The true universe may be far larger still, perhaps unimaginably larger, the visible part a mere island within a far greater whole. The bigness of the world, which might seem to demand a grand cause, finds its source in a single early breath. Just how much larger the whole cosmos might be depends on how long inflation lasted, and if it ran for many more doublings than the bare minimum, the true universe could dwarf the visible part beyond all reckoning. The puzzles of smoothness and flatness need only 60 or so doublings to be solved, but nothing forbids inflation from having gone on far longer, stretching space through hundreds or thousands of doublings before it ended. Each additional doubling would multiply the true size of the cosmos again, until the visible portion became a vanishing speck within an expanse too vast for any number to hold. To linger on that is to glimpse the possibility that all we can ever see is the tiniest fragment of a whole, almost infinitely greater, a single grain within an unthinkable immensity. Even the soft darkness of the night between the stars owes something to that first stretching, for inflation, smoothing and seeding shaped the whole arrangement of light and shadow overhead. The great expansion set the wide spacing of the galaxies, the vast dark gulfs between them, the thin scattering of stars across a deep and shadowed sky. Were the cosmos not so smoothed and so widely stretched, the heavens might be a very different place, crowded or chaotic, without the calm dark in which the stars rest like scattered embers. The peaceful darkness above you on any clear night, the deep black in which the points of light are set, is itself a distant gift of that first instant's work. There is a deep comfort in knowing that the very spaciousness of the cosmos, its enormous room, was made in that first flickering breath. The universe is not cramped or close, but vast and open, full of distance and dark, an expanse in which everything has room to rest. That spaciousness was the gift of inflation, the stretching that gave the cosmos its breadth and its wide emptiness, opening such immense gulfs between the galaxies that each one floats far from its neighbours across millions of light years of empty dark, with room to drift undisturbed for billions of years. That same early breath also explains why the universe looks so similar in every direction, why the sky is so evenly furnished with galaxies wherever you turn your gaze, because all that we see grew from a single tiny patch, smoothed and stretched together. The cosmos carries that early uniformity everywhere, the same kinds of galaxies, the same scattering of light in every direction at once. Look toward one horizon and you find the same broad sameness as toward the other, not because the distant regions ever spoke to one another, but because they share a common origin in that first small patch. The deep evenness of the heavens, which so puzzled the early watchers, becomes natural and unsurprising once you know that the whole sky was once gathered, warm and uniform, into something smaller than a grain of dust. There is a reassurance woven through all of this, in the way inflation turns coincidence into consequence, mystery into meaning. The smoothness, the flatness, the great size, the missing relics, all the things that seem like impossible luck become, in the light of inflation, the natural results of a single early event, neither tuned by chance nor balanced by accident, but produced by the unfolding of the great stretching. There is a deep calm in that, the sense that the universe is not a precarious fluke, but the orderly outcome of a process, its suitability for stars and worlds flowing from a cause rather than a wild coincidence, like water finding its level. To feel just how delicate the balance was, consider once more the flatness of space, and the staggering precision the early universe would have needed without inflation to lend it a hand. For the cosmos to lie as flat now as our instruments find it, its geometry at the very beginning would have had to be balanced to something like one part in many, many trillions, a tuning so fine that the smallest imaginable deviation would have grown, across the ages, into a wildly curved and lifeless world. Such precision, arising by mere chance, would be a coincidence almost too large to believe. But inflation dissolves the need for any such luck, for the great stretching drives space toward flatness all on its own, flattening any curve by the sheer scale of its expansion, the way the steep face of the earth fades to a level plane when you stand small upon so vast a sphere, any curve smoothed away by sheer immensity. What once demanded impossible fortune becomes, instead, the natural work of a single instant. The flatness that inflation promised has been measured in our own age with quiet precision, and the answer comes back astonishingly close to perfectly level, just as the theory foretold. By studying the pattern of the ancient glow and the great web of galaxies, those who measure such things have found the geometry of space to be flat to within a tiny fraction, so near to perfectly level that any curve, if it exists at all, must be gentler than almost anything they can detect. This is a remarkable confirmation, for inflation predicted exactly this near-perfect flatness, and the universe has answered in kind. To know that the space around you is level to such exquisite precision is to feel the great smoothing of that first instant still holding true, the geometry of the cosmos resting on its knife's edge. There is a further wonder in how those magnified quantum tremblings became, in time, the solid and settled ripples that shape the galaxies, a strange passage from the uncertain to the certain. In the quantum world, things are blurred and unsettled, holding many possibilities at once, and yet the ripples inflation left behind are definite and fixed, real features printed firmly into the cosmos. As the great stretching carried each trembling far beyond the reach of any further change, It seems to have settled them out of their quantum haze into lasting classical form, the blurred made clear, the possible made actual. To follow that change is to glimpse one of the deepest mysteries in physics, the strange passage by which the uncertain shimmer of the very small hardens into the firm and ordered world, the trembling haze of a single field cooling at last into galaxies set in their fixed and final places. Inflation may also help to explain one of the most profound features of the whole universe, the fact that time seems to flow in a single direction from a more ordered past toward a less ordered future. The cosmos began, it appears, in a state of remarkable smoothness and order, and everything since has unfolded toward greater disarray, which is why we remember the past and not the future, why the broken cup does not mend itself. The great smoothing of inflation may be the very source of that ordered beginning, setting the universe down in so calm and even a state that the long slide toward disorder, the very flow of time we feel, could begin. There is something deep in the thought that the direction of time itself may trace back to that first quiet smoothing. The smoothing power of inflation is so thorough that it would erase almost any unevenness the universe began with, no matter how rough or wild its earlier state, and there is a deep comfort hidden in that thought. Whatever chaos or lumpiness the cosmos may have carried before the great stretching, inflation would have stretched it smooth, spreading any wrinkle across so vast a new expanse that it all but vanished, leaving the smooth, even sky we find today. This means the universe did not need to begin in any special or finely arranged condition. It could have started rough and disordered, and inflation would still have ironed it into the calm and uniform cosmos we know. There is a grace in a process that can take almost any beginning and smooth it into order, that asks so little of the start and gives so much to what follows. Inflation also reshapes the very meaning of the moment we sometimes call the birth of the cosmos, softening the picture of one violent instant into something subtler and stranger. The old image was of everything erupting from a single point in a great burst, but inflation quietly complicates that picture. For the wildest expansion came not from a fiery explosion of matter, but from the relentless stretching of empty space driven by a field. The heat and the light, the true blaze of the early universe, came afterward, in the reheating, when the field poured out its energy at inflation's end. So the beginning, in this telling, was not one event but a sequence, a stretching followed by a kindling, the cold and silent swelling of space giving way to the warm and glowing cosmos. The story grows richer the more closely it is held. Because of this, the very phrase we use for the birth of the cosmos has shifted its meaning, for what many now call the Great Beginning is not the first instant at all, but the hot, dense moment that followed inflation's close. The familiar picture of a fiery young universe cooling and expanding describes the world after the great stretching ended and the field poured out its heat, not the silent stretching that came before. Inflation sits earlier still, before the fire, the cold and swift prelude to the warmth we usually imagine as the start. There is something humbling in that, the realization that the beginning we long pictured was itself a second act, with an even stranger and quieter first act hidden before it. This means the deepest origin of all, the true first instant, lies even further back than the warm beginning, in a realm so extreme that our finest theories grow uncertain there. What came before inflation? What set the field upon its high perch? What the very first moment was truly like? These remain among the greatest open questions, reaching into conditions where our understanding of space and time begins to fray. Inflation reaches closer to that ultimate origin than any other idea, yet it does not quite arrive, leaving the very first instant veiled. There is a hushed wonder in drawing so near to that final question and finding it still unanswered, the deepest beginning hidden behind a last thin curtain, just past the edge of everything that can be known. It is humbling to remember how recent this whole understanding is, how young the very idea of inflation truly is in the long history of human thought. For nearly all of the ages that people have gazed at the sky and wondered at its origin, no one imagined anything like this, No one dreamed that the universe might have swelled from a speck in a flicker of time, driven by an invisible field. The idea is younger than many who are alive today, born only a few decades ago in the mind of a single curious physicist, puzzling over missing magnetic relics. To hold so vast a notion and know it is so new is to feel the freshness of human understanding, the sense that we are still in the early morning of learning how the cosmos came to be, with so much still unknown and so much still to find. And yet, young as the idea is, it has already woven itself deeply into how we understand nearly everything about the early universe, for it touches so much at once. The smoothness of the ancient glow, the flatness of space, the seeds of the galaxies, the absence of the heavy relics, the very size of the cosmos, all of these find their explanation in that single early event. Few ideas in all of science reach so widely, gathering so many separate mysteries beneath one roof, and that breadth is part of why inflation has endured and grown despite all that remains uncertain. To explain one puzzle is a fine thing, but to dissolve so many at once with a single elegant stroke is rarer and more beautiful by far. Let that elegance rest in your mind, the satisfaction of many troubles soothed by one idea. The inflaton field, the unseen engine of it all, remains one of the great open questions, for no one yet knows exactly what it was, and there is a deep mystery in that uncertainty. Physicists can describe how the field must have behaved, how it held its energy and rolled slowly down, but they cannot yet say with confidence what kind of thing it truly was, whether it connects to the known forces and particles of nature or stands somehow apart. Many possibilities have been imagined, many candidate fields proposed, each painting the first instant a little differently. The search to discover the true nature of the inflaton, to learn what actually drove the great stretching, is among the deepest quests in the study of beginnings, a mystery still patiently unfolding, its answer perhaps hidden in the faint swirl of ancient light we have not yet caught. There is a marvel in the fact that the very shape of that early plane, the shallow slope down which the field rolled, can in principle be read from the sky itself, reconstructed from the faint patterns the great stretching left behind. The tilt of the ripples, their balance across scales, the faint swirl of primordial waves if it is ever found, all of these carry within them the imprint of how steeply or how shallowly the field descended. By measuring them with care, those who study the beginning hope to draw out the very form of that hidden landscape, to map the slope the universe rolled across before there was anything at all. It is a wondrous thought, that a shape from the first instant of time might be recovered from light gathered ages later beneath the stars. When the field finally released its energy and kindled the cosmos into warmth, the heat it produced reached a particular height, and from that first warmth all ordinary matter slowly took its form. The temperature of reheating, the warmth struck when inflation ended, set the stage for everything that followed, hot enough to forge the conditions from which the familiar particles of the world would emerge. From that early heat came, in time, the ordinary matter that fills the cosmos, the very stuff of stars and worlds and living things, all of it kindled into being in the warm aftermath of the great stretching. To know that the matter of your own body traces back to the heat of that single kindling is to feel an unbroken thread running between the first instant and the warm flesh resting here in the dark, every atom of you struck from the same fire that ended inflation. It is a curious wrinkle that the field's energy, which was so enormous during inflation, somehow gave nearly all of itself away at the end, leaving the empty space of today almost free of it, and this poses one of the deepest puzzles in physics. The vacuum brimmed with energy in the first instant and drove the great stretching, yet the emptiness around you now holds only the faintest trace of such energy, vanishingly small by comparison. Why the enormous early energy drained away so completely, leaving so faint a remnant, is a mystery no one has fully solved, a riddle at the very heart of how emptiness behaves. There is a humbling beauty in that open question, the universe still keeping a secret about the nature of the void in which everything rests. Whatever that field was, its energy during inflation was vast beyond easy telling, far greater than anything ever produced in the present universe, even in the fiercest collisions our machines can make. The conditions of that first instant reached energies so high that they brush against the very edges of known physics, the realm where our deepest theories begin to strain and blur. Inflation in this way is a window onto energies we can never recreate, a glimpse of the universe under conditions far beyond our reach, and to study it is to study physics at its most extreme. There is a strange thrill in that, the thought that by reading the faint patterns in the sky, we may learn about energies and forces that no laboratory could ever hope to summon, the cosmos itself serving as the only experiment that ever ran at such a scale. Because inflation reaches into such extreme conditions, it sits close to one of the greatest unsolved riddles in all of physics, the long-sought union of gravity with the rules of the very small. The earliest instant of the universe, where inflation took place, is a realm where both the force of gravity and the strange laws of the quantum world matter at once, and we have no complete theory that joins the two. Inflation, by bringing us so near to that frontier, may one day help to light the way toward that deeper understanding, the grand theory that would weave gravity and the quantum together into one. To study the first sliver of time is, in this sense, to press against the boundary of everything we know, where the answers we seek may finally lie. The universe keeps its deepest secret precisely where it began. As the night grows long and your thoughts begin to loosen, the mind drifts among these vast ideas without needing to hold any of them tightly, and that is exactly as it should be. There is nothing here to master, no lesson to carry into the morning, only the wandering through wonders far larger than any worry. The universe stretched and smoothed and seeded itself long before there was anyone to understand, and it will keep its long course whether or not a single fact stays. The great numbers may blur and the strange fields dissolve, drifting away into the warm dark like the first stars fading at the edge of dawn. The faint ripples that inflation froze into the early universe did more than seed the galaxies. They also set the largest patterns of the cosmos, the great web that the galaxies trace across the dark. Look out far enough, and the galaxies are not scattered evenly but gathered into long filaments and great walls, with vast empty voids between them, a delicate cosmic web spanning the whole reach of space. That immense structure, the grandest pattern in all existence, grew directly from those first faint variations, the slightly denser regions drawing matter together into the threads of the web, the slightly emptier ones thinning into the great hollows. The architecture of the entire universe, on the largest scale there is, was sketched in the quantum tremblings of inflation's first instant, a blueprint drawn in whispers and then built across billions of years. There is a particular scale, vast almost beyond imagining, above which that great web smooths away entirely, and the universe becomes smoothly uniform, looking much the same no matter where you sample it. On smaller reaches, the cosmos is lumpy, gathered into galaxies and clusters and the threads between, but step back far enough, across hundreds of millions of light years, and all that structure blurs into an even sameness, the lumps averaging out into a smooth, even whole. This great smoothing at the larger scales is exactly what inflation foretells, the early evenness it wrought still ruling the cosmos on its grandest reaches. To know that the universe, for all its nearby structure, becomes perfectly calm and uniform when seen broadly enough, is to feel the deep tranquility woven into it at the start. That same common origin may explain something we usually take for granted, the fact that the laws of nature appear to be the same everywhere we look, in every distant galaxy and every far reach of space. Because everything within our horizon was drawn from one small region, ironed flat and blown wide as one, it shares not only a common temperature but a common nature, the same physics ruling throughout, the same forces and the same rules holding from one edge of the visible cosmos to the other. The deep uniformity of the laws, which lets us understand distant stars by the physics we learn at home, may itself be a gift of that shared beginning. There is a profound reassurance in that sameness, a universe governed by one order everywhere at once. When astronomers map that great web and study how the galaxies are spread, they find a pattern that once again matches what inflation predicts, lending the idea yet another confirmation. The way the galaxies cluster, the typical sizes of the filaments and voids, the even statistics of how matter gathers across the sky, all of it agrees with the kind of ripples inflation is thought to have sown. To find the same early fingerprint in two such different places, in the ancient glow and in the modern web of galaxies, is to see the theory's predictions confirmed twice over, by light from the dawn of time and by the great structures that light eventually became. There is a deep coherence in that, the sense of a single story told consistently across the whole of cosmic history, from the first instant to the present sky. Among the gentlest predictions of inflation is that those primordial ripples should be very nearly the same in every direction and across every scale, a quality physicists describe with a word that means without favoured size or place. The variations the great stretching left behind do not pick out any special direction, nor any special scale as wildly different from the rest, but spread themselves with an even hand across the whole cosmos. This featureless fairness is exactly what inflation foretells, for the great expansion treats all directions and all scales alike as it stretches the tiny tremblings to cosmic size. And when the ancient glow and the galaxy web are measured, this gentle evenness is indeed what appears, the ripples carrying no favoured direction, no special scale, just the smooth and balanced sharing the theory promised. That gentle sameness in every direction has itself been tested with great care, and the universe has answered that it is, as far as we can measure, beautifully even all around, with no direction set apart from the rest. When the ancient glow is mapped across the entire sky, its warmth reads almost exactly the same toward every quarter of the heavens, the tiny variations scattered without any grand tilt or favoured axis. This deep evenness across all directions is precisely what inflation foretells, for the great stretching smooths the cosmos the same way everywhere at once. To know that the sky is so uniform wherever you turn, balanced and even to such fine precision, is to feel the great smoothing still holding true across the whole vault of night. The farthest thing any eye or instrument can ever see is that ancient glow itself, a kind of softly glowing wall marking the edge of the observable universe, the boundary beyond which the early cosmos was too foggy for light to cross. That wall is not a true edge of the universe, but only the limit of our sight, the most distant surface from which light has had time to reach us, the soft horizon of all our seeing. Inflation tells us that the true cosmos reaches far past that glowing boundary, the observable part a mere island within a vastly greater whole. To rest beneath that soft horizon is to know yourself held within a small lit room whose walls are made of the oldest light, while the true house extends dark and immense far beyond. What we can see is, in the end, only a single patch of a far larger cosmos, the one small region whose light has had the time to find us, and there is a deep humility in dwelling on that. Beyond our horizon lie reaches we can never glimpse, not because they are hidden, but because the light from them has not yet had long enough to cross the gulf, and some of it never will, carried away by the ongoing expansion. We see one small island of light in an immeasurable ocean of space, and inflation suggests the rest is much like ours, smooth and even, filled with the same scattering of stars. There is peace in being one bright shore within so vast a calm, asking nothing, simply resting where the light happens to reach. There is a small, almost philosophical comfort in that evenness, in knowing the universe shows no preferred direction, no special place that stands above the rest. Wherever you might stand within the cosmos, on whatever distant world beneath whatever far sun, the great pattern would look broadly the same web of galaxies, the same scattering of ancient light. No corner of the universe is the centre, and none is the edge. The deep sameness inflation wrought makes every place, in a sense, equally at home within the whole. There is a belonging in that thought. The knowledge that your own small place beneath the stars is no less central, and no more than any other in all the vastness, that you rest exactly where the universe is just as much itself as anywhere. There is a further elegance in how those ripples repeat their even character across every size, so that the pattern of variation looks much the same whether you study vast reaches or smaller ones, a kind of self-likeness woven through the cosmos. The great stretching, treating all scales alike, left a pattern that echoes itself from the largest spans down to the small, the same even statistics holding wherever you look. This repetition across scale is one of the loveliest hallmarks of inflation, a self-similar grace printed through the whole structure of the heavens. To know that the universe carries the same delicate signature at every size is to feel a deep harmony in its making, one pattern echoing softly through all the reaches of space. There is a harmony in a cosmos patterned the same way at every scale, ordered and even from the grandest web down to the faintest ripple. Nothing in such a universe is harsh or discordant, only a repeating order, the same delicate signature printed whether you study reaches of 1 billion light-years or the smallest variation in the ancient light. The pattern echoes itself across all the spans of space, one self-similar grace running unbroken from the largest structure there is to the faintest seed within it. The smoothness inflation gave the early universe is in truth a delicate and surprising achievement, for there was no reason the cosmos had to begin so calm, and the wonder of it deserves a slow pause. The universe could have started wild and roiling, lumpy and chaotic, full of violent differences from place to place, and had it done so, the sky would be a turbulent ruin rather than the serene and even expanse we find. That the cosmos is instead so smooth, so uniform across its vast reaches, is precisely the gift inflation gave, ironing the early roughness flat, settling the young universe into the deep tranquility from which all order could grow, the calm of the night sky. The deep evenness of the heavens is itself a distant inheritance from that first great smoothing, a piece woven into the world at its very beginning. It is a curious and lovely thought that the very calm in which you now rest, the quiet order of a universe fit for stars and sleep, traces back to an event of almost unimaginable violence, the most explosive stretching the cosmos ever knew. The frantic, ferocious doubling of inflation, wild beyond any fury that came after, is precisely what produced the deep and lasting tranquility of the world, the smoothness that let everything slowly form. There is a strange paradox in that, the most violent beginning giving rise to the most peaceful order, the great storm at the dawn of time settling into the long calm of all that followed. The universe found its peace through its first wild motion, and you rest now in the quiet that motion made. There is a delicate balance hidden in the strength of those first ripples, for had they been much stronger, the universe would have collapsed into dense knots too quickly for calm worlds to form, and had they been much fainter, nothing would ever have gathered at all. Inflation left them at just the right faintness, a few parts in 100,000, strong enough to seed the galaxies yet faint enough to let them form slowly and well. That the ripples came out so finely balanced, neither too deep nor too shallow, is part of why the cosmos became a place where stars could kindle and worlds could cool. There is a quiet wonder in that gentle measure, the seeds of everything sown at exactly the softness the universe needed. The work those ripples began is not yet finished, for matter is still gathering across the cosmos even now, the great web drawing itself tighter across the ages. The faint variations inflation froze into the early universe are still at their patient labour, pulling matter together, building and refining the structures of the heavens long after the first instant that sowed them. Galaxies still drift toward one another, clusters still slowly form, the architecture of the cosmos still taking shape from those ancient seeds. To know that the first instant's gift is still unfolding, still building the universe around you, is to feel how the beginning reaches on into the present and onward into all the time to come. Those first faint ripples drawing the galaxies inward even tonight, even now. As you drift here in that inherited calm, consider how strange and wonderful it is that the cosmos can be understood at all, that its first sliver of a second has left clues a patient mind can read. There was no promise that the universe would be comprehensible, no guarantee that its deepest beginnings would leave any trace, or that creatures grown from its ancient ripples could ever come to grasp them. And yet the cosmos is generous with its secrets, scattering them in the faint patterns of ancient light and the great web of galaxies, waiting for any patient watcher to gather and read. There is a deep and humbling beauty in that, the universe somehow knowable, somehow legible, its first breath written softly into a sky that we, its distant children, have learned to study. The fact that we can know any of this at all is perhaps the gentlest wonder of them all. Inflation, for all its grandeur, was over almost before it began, a flicker of an instant that nonetheless shaped all the long ages to come, and there is something dreamlike in that disproportion. The entire episode, the great stretching that smoothed and flattened and seeded the universe, lasted a span of time so brief that no word for shortness can hold it, far less than the blink of an eye, far less than the shortest flicker you could ever imagine. And yet from that vanishing instant flowed everything, all the billions of years, all the stars and galaxies and still evenings, the whole long unfolding of the cosmos. The briefest of moments set the stage for the longest of stories, a flash at the beginning whose consequences are still unfolding around you now, in the slow turning of the night. To hold that thought, the enormous born from the instantaneous, the eternal from the fleeting, is to touch the deep strangeness and beauty of time itself. The universe did its most decisive work in less than a heartbeat, and has been living out the consequences ever since, across spans of time too vast to feel. You, lying here in the dark, are one of those consequences, a distant result of that first swift breath, a small warm gathering of matter whose lineage runs all the way back to the flicker that began everything, a story that opened with a single instant's grace. The same quantum trembling that inflation magnified into galaxies still fills the empty space around you in this very moment, a faint shimmer woven into the fabric of the room. Down at the finest scales, nature itself forbids perfect stillness anywhere, so that even the emptier space hums faintly with energy, flickering up and down, the same kind of trembling that once seeded the cosmos. This is not some distant and vanished thing, but a living quality of emptiness everywhere, present in the space between your hands, in the air above your bed, in every gap and hollow of the world. The universe is restless at its smallest scales, even now, faintly shimmering, and from that same restlessness, magnified long ago, came everything you have ever seen. There is a soft intimacy in that, the seeds of galaxies and the trembling of the space beside you sharing one nature. It is a tender thought that the very emptiness around you tonight, the still air above the bed, the dark of the room, carries within it the faintest echo of that same restless trembling from which the galaxies grew. The space you rest in is not a dead and barren void, but a softly humming fullness, alive with the same faint flickering that once seeded the stars, present in every corner of the night. You are wrapped, even now, in a kind of living calm, an emptiness that trembles ever so faintly, the same nature that built the cosmos cradling you in the dark. There is a soft intimacy in resting within that faint shimmer, held by the very stuff from which everything was made. That restless quantum shimmer is so fundamental that it can never be stilled, never quieted to perfect calm, for the very rules of nature forbid it, and in this there is a strange reassurance. No matter how cold a thing becomes, no matter how empty a region of space, the faint trembling remains, a ceaseless motion that nothing can ever switch off. It is woven into the deepest fabric of reality, an irreducible restlessness at the heart of all things, the same restlessness that, blown vast by inflation, gave rise to the stars. To know that even perfect emptiness can never be wholly still is to feel that the universe is alive at its very roots, humming everywhere and always, a perpetual motion underlying the calm of the night. It is worth dwelling, with gratitude, on the simple fact that without those faint frozen ripples, there would be no structure anywhere, no galaxies, no stars, no worlds, only a featureless mist drifting forever through an empty dark. Everything that gathers, everything that shines, everything that holds together against the smoothness of space owes its very existence to the faint unevenness inflation left behind. The night sky full of stars, the warm sun, the solid ground, all of it stands upon those first faint variations, the difference between a barren haze and a cosmos rich with light. To rest in a universe furnished with stars is to rest upon the gift of that faint imperfection, the small unevenness that made everything possible. There is a tender thought folded into all of this, that you're here to wonder at the beginning precisely because the beginning unfolded as it did, smoothing and seeding the cosmos into a place where minds could one day arise. Had inflation made the universe perfectly smooth, no galaxy would have formed to hold a star, no star to warm a world, no world to cradle a watching mind, and there would be no one at all to marvel at the first instant. That you can lie here and contemplate the great stretching is itself a distant consequence of that stretching, the cosmos grown, through its faint unevenness, into something able to know itself. There is a soft circle in that, the beginning giving rise across the ages to the very wonder that now turns back to gaze upon it. The energy that inflation released at its end, in the great reheating, became in time every particle of matter and every ray of light that fills the universe today, and to trace that lineage is to feel a deep connection to the first fire. The atoms in your body, the light of every star, the warmth of every sun, all of it descends from the energy the dying field poured out when inflation closed, the flood of fire that filled the newly enormous cosmos. That ancient outpouring was the source of all the matter and energy that would ever be, the single wellspring from which everything material flowed. To follow that lineage is to know yourself made, in the most literal sense, from the energy of inflation's ending, a small enduring portion of that first great kindling, the atoms of your slow breath still carrying, across all the ages, a trace of that distant fire. Before that kindling, in the depths of inflation itself, the universe was cold and dark and empty, almost the opposite of the fiery beginning we sometimes imagine, and there is a beauty in that unexpected stillness. While the great stretching ran, space held little but the energy of the field, no blazing heat, no swarming particles, only the silent, frigid expanse swelling ever wider in the dark. The fire came only afterward, at inflation's end. The stretching itself unfolded in cold and silence, a vast and soundless swelling of empty space. There is something surprising in that picture, the most dramatic event in cosmic history taking place not in roaring flame but in dark and frozen silence, the universe widening into immensity through a great and wordless hush. To imagine that silent swelling dark is to touch something close to pure stillness, a universe expanding in perfect silence, and you may let that image settle over you like a weightless blanket. There was no sound, for there was nothing yet to carry it, no light, for the fire had not yet been kindled, only the cold, smooth, silent stretching of space, vast beyond telling. It is among the most peaceful pictures the cosmos offers, this frozen, soundless swelling at the dawn of everything, a hush so deep it preceded even heat and light. There was only the dark and the cold, and the smooth expanse opening wider and wider, in a silence with nothing in it at all, no spark, no whisper, no warmth, only space itself unfurling endlessly outward, like a held breath that has not yet been let go. The amount that space grew during inflation is so far beyond ordinary numbers that physicists must reach for special ways to write it, stacking powers upon powers just to hold the figure, and there is a wonder in a growth that strains the very language of mathematics. To say the universe grew by 100 trillion times is only the barest lower estimate. In many versions of the theory, it grew by vastly more, by factors so enormous that they cannot be written out in full but only hinted at through towering arrangements of numbers. The mind cannot truly hold such growth, and it need not try. It is enough to feel the sheer immensity of it, an expansion so great that our largest ordinary measures fall away like dust before it. The universe outran every number in its first instant, and we are left only to marvel at the scale. Yet however vast that growth, what we can see of its result is only a small part of the whole, for the visible universe is merely the portion whose light has had time to reach us, a single lit window in a far larger and darker house. Beyond the edge of what we can observe, the cosmos almost certainly continues, stretching on through reaches we will never glimpse, the true universe perhaps vastly larger than the part that meets our instruments. Inflation suggests this strongly, for the great stretching would have carried much of the cosmos forever beyond our sight, swelling space so widely that most of it lies past any horizon light could ever cross. To sit with that is to feel the humility of our small bright patch, a knowable island within an unknowable immensity, the faint light of countless galaxies still racing toward us, across distances so deep that most of the cosmos will remain forever past the reach of any eye. That hidden vastness means there may be regions of the universe utterly unlike our own, born from the same inflation but settling into different forms, and the thought carries a soft and dreamy strangeness. In the picture of eternal inflation, where the great stretching never wholly stops, the countless pockets that settle out of it might each cool into a cosmos with its own character, perhaps its own subtle laws, its own arrangement of matter and force. Some might be barren, some might brim with stars, and we could never know, for the inflating space between would forever keep them beyond reach. There is a wonder in imagining such hidden variety, a foam of worlds each going its own way, and a deep comfort too in resting within just one, this single calm pocket that happened to cool into a place where you could be. Whatever lies beyond our seeing, the universe we do inhabit bears everywhere the faint marks of its inflationary birth, and to notice them is to feel the past alive in the present sky. The smoothness overhead, the flatness of the space you move through, the great web of galaxies, the faint and ancient glow. All of these are the lingering signatures of that first swift stretching, written into the very structure of the world around you. You do not need a telescope to live among them, for they are the silent conditions of existence itself, the calm and ordered cosmos in which your life unfolds. To know that the peace of the night and the order of the heavens are the distant fruit of inflation is to feel how seamlessly the first instant joins to this one, that same early stretching still shaping the smooth dark and the steady stars above the bed where you now rest. There is a particular comfort in the way inflation makes the universe feel less like an accident and more like the natural unfolding of a single law. The cosmos did not have to be balanced just so by some impossible stroke of luck. It grew into its order through a process, the great stretching shaping it towards smoothness and flatness, as surely as water finds its level. There is a deep ease in that, the sense of living in a universe that makes a kind of sense, its suitability for stars and life flowing from a cause rather than a fragile coincidence. A whole cosmos eased into being by one unhurried descent of a field. The story of inflation is, in the end, a story of how the very small became the very large, how the faintest tremblings grew into the grandest structures, and there is a deep harmony in that arc that the mind can rest within. From quantum whispers came galaxies. From a speck smaller than an atom came all the reaches of space. From a flicker of an instant came the long ages of the cosmos. The smallest gave rise to the largest, the briefest to the longest, in a single graceful sweep that joins the two ends of all scale into one continuous tale. To hold that arc gently is to feel the unity of things, the deep connection between the tiniest flicker and the widest sky, all of it one story, slowly unfolding, with you resting somewhere quietly within it. That arc reaches all the way down to you, lying here in the warm dark, for you two are a small thing grown from the same beginning, a gathering of matter that descends from inflation's first faint ripples. The atoms within you trace their lineage back through stars and clouds, to the energy that the dying field released, and the very pattern that let your galaxy form was sown in that first instant's trembling. You're not separate from this grand story, but a part of it, a living continuation of the great unfolding, the cosmos grown briefly aware of itself in the form of a resting mind, woven into the oldest tale there is. The deeper one looks into inflation, the more it reveals about the strange and beautiful nature of time, for it suggests that even time itself may have a kind of beginning, a place where the ordinary flow first took shape. Before inflation, in the conditions of the very first instant, time and space were so woven together and so extreme that our usual sense of before and after begins to blur and lose its meaning. Inflation marks, in a way, the point where the familiar march of time settled into the steady flow we know, the moment the cosmos began to keep its long, slow clock. To contemplate a beginning of time itself is to touch the very edge of thought, a deep mystery at the root of everything, and there is an awe in resting so near to it, here in the depths of the night. There is a soft humility in realizing that we, latecomers by billions of years, can nonetheless reach back in understanding to that first faint fraction of a second, reading the universe's birth from the patterns it left behind. We arrived long after the great stretching, long after the fire and the cooling and the slow gathering of stars, and yet through patient watching we have learned to glimpse the very beginning, to infer the first instant from the ancient glow and the web of galaxies. There is something deeply moving in that reach across time, the children of the cosmos peering back toward their own origin, piecing together the story of a moment that happened before there was anyone at all. The universe left a faint trail for us to follow, and follow it we have, all the way to the edge of the beginning. That trail of clues is what keeps inflation a living science rather than a settled myth, for there is always more to measure, always a finer pattern to seek, and the search itself is a patient kind of devotion. Each new map of the ancient glow, each deeper survey of the galaxies, each more sensitive hunt for the swirl of primordial waves, refines our picture of that first instant and tests the theory anew. The story is not finished, and that unfinishedness is part of its beauty, a great question still open, drawing patient minds onward season after season. There is a reassurance in that endlessness, the sense that the universe will go on offering its secrets to those who keep watch, the search continuing beneath the same stars under which you now rest. For all the deep questions that remain, the central idea has held remarkably firm across the decades, weathering test after test, and there is a strength in an idea that endures. Many notions in science rise brightly and then fade as the evidence turns against them, but inflation, for all its mysteries, has met the measurements again and again, its predictions confirmed both in the oldest light and in the vast scaffolding the galaxies trace across the dark. It is not beyond all doubt, and honest minds hold it lightly, but it has proven a sturdy and fruitful idea, shaping how we understand the beginning more deeply than almost any other. There is a comfort in that durability, the sense of resting upon an idea that has earned its place, tested and confirmed across the patient years. And yet the very best ideas in science leave room for surprise, and inflation may still hold revelations no one has yet imagined, hidden in the faint patterns waiting to be read. Perhaps the swirl of primordial waves will one day be found, confirming the great stretching beyond doubt. Perhaps the true nature of the driving field will be revealed. Perhaps something stranger still, some twist no one has foreseen, lies waiting in the data yet to come. The story of the beginning is not closed, and the cosmos may yet astonish us, offering some new wonder from its first instant that deepens or transforms all we think we know. There is a quiet excitement in that openness, the sense of a tale still unfolding, with its most beautiful chapters perhaps still ahead. To live in the midst of such a story, while it is still being written, is a rare privilege. You live in an age when the beginning of the universe is being read from the sky, when patient minds reach back toward the first instant and the great question slowly clarifies. You need do nothing to take part in it, but rest beneath the same heavens, held by the same cosmos whose birth is being uncovered season after season, a time when the first breath of everything is slowly coming into view. The image at the heart of it all, the speck that became everything, is worth returning to gently, for there is a deep tenderness in holding the whole cosmos as it once was, small enough to vanish. Everything you can see, every star and galaxy, every reach of space, was once gathered into a fullness finer than any speck you could ever point to, warm and smooth and trembling faintly in the dark. From that vanishing fullness, in a flicker, came all the room the universe would ever need. To hold that image as you drift towards sleep is to cradle the beginning of all things in the quiet of your mind, the entire cosmos resting for a moment, as it once truly rested, tiny and complete, on the edge of its great unfolding. There is a soft symmetry in ending the night where the universe began, with smallness and stillness and the quiet edge of an immense becoming, and you may feel that symmetry settle gently around you. The cosmos started small and silent and grew vast. You began the night awake and busy, and now grow still and small in the warm dark, sinking toward the quiet from which all rest comes. There is a gentle rhyme between the two, the universe folding outward from its speck, and you folding inward towards sleep, both of you moving softly toward where you're meant to be. Let that quiet rhyme carry you onward, the breathing unhurried, the limbs grown weightless, the thoughts loosening toward the stillness at the heart of the night. As these vast ideas grow soft and distant, you may feel the room itself settle more deeply around you, the dark drawing closer and gentler, the night holding you with an easy and unhurried care. There is nothing left to follow, no number to keep, no field or fluctuation to fix in mind, only the slow and pleasant drift downward into rest. The cosmos did its flattening and its sewing in a single flicker, long before you were born, and it wishes nothing from you tonight except that you let yourself grow quiet within it. Let the thoughts loosen and dim, let the great story fade to a soft warmth somewhere beneath thought, and let the night carry you gently towards sleep. And as the long night gathers toward its close, there comes one final wonder, the gentlest and most quietly astonishing of all, the thought the cosmos is saved for the very end. Hold once more in your mind that first vanishing speck, smaller than an atom, warm and smooth and trembling, and remember all that it became, every star, every galaxy, every reach of space, and the slow gathering of worlds, and at last a quiet mind drifting towards sleep beneath the heavens. All of it, everything that has ever been or will ever be, unfolded from that single tiny seed in a flicker of time, blown vast by the great stretching, kindled into fire, cooled into stars. The whole immensity of existence, the entire universe in all its grandeur, grew from something smaller than the smallest thing, in less than the first breath of the first second of all. And here is the final secret folded quietly within that thought. The faint quantum tremblings that inflation magnified into galaxies are the very same kind of tremblings from which you, in the long fullness of time, were eventually made. The pattern that let your galaxy gather, the seed that drew together the cloud that became your sun, the lineage of every atom in your slow breath, all of it reaches back to one of those minute flickers, lifted up and frozen into the universe in its first instant. So when you contemplate that great beginning, something very old within you is contemplating its own deepest origin. The resting mind and the first faint ripple, revealed at last to be one continuous thing, joined across all the ages of the cosmos. You're not a stranger to the universe's birth, but a distant living echo of it. The faintest trembling of the beginning grown across unimaginable time into a heart beating softly in the dark. There is nothing at all you need to do with this, nothing to keep or to carry into the morning. It is enough tonight simply to have felt it for a single quiet moment, the gentle kinship between yourself and the first instant of everything, the soft truth that you belong to the cosmos as fully and as surely as any star, that the same beginning that made the galaxies also, in time, made you. The long, slow wandering through the birth of the universe is complete now, and you may set all of it gently down, every fact and figure and far-flung wonder. There is nothing more to follow, nothing more to learn, nothing more the night asks of you. And if you are still here, drifting softly in the dark, another quiet journey is already waiting for you, there on the screen whenever you wish it, or never at all. It will keep patiently for as long as you like. There is no need to reach for it now. It will simply be there, the way the stars are always there, asking nothing, offering only their gentle presence whenever you choose to return. For now, let everything you have heard tonight grow distant and dim. Let the great numbers fade, let the vast stretching soften, let the speck that became the universe slip slowly back into the wide and peaceful dark, where its long story will go on without any need of your watching. You do not have to hold on to a single thing. Let the breath grow slow and easy. Let it rise and fall and rise again, all on its own. Feel how heavy and warm the body has become. Feel how the bed holds you, how the dark wraps softly around you, how safe and quiet this moment is. There is nowhere to go. There is nothing to do. There is only this gentle settling, this slow letting go, this quiet drift downward into rest. The universe is unfolding. The night is deep, and you are held. Let the thoughts grow quiet now. Let them dim one by one, like the first stars softly fading at the edge of dawn. Rest now. Let go. Sink slowly into sleep. And now, 101 wonders are resting with you. Sleep now. Good night.